Today our topic is linear functions. So our learning target is how can I evaluate using function notation. First off, some vocabulary. We have linear function, a relation that relates one input to exactly one output that creates a straight line. So if something is linear, it creates a straight line. Function notation is an equation in y equals or f of x equals. So like y equals 3x plus 2. That would be in function form. Or f of x equals 3x plus 2. It's function notation. So those two are the exact same equation, just notated differently. One has a y equals, one has f of x equals. So they are interchangeable. Independent variable is our input variable. It's what we are putting into our function. We can determine whatever it is. So that's usually x. So if you think about making a input-output table, we can always choose the values for x. We could choose 0. We could choose -4. We could choose 99. What we can't choose is our values for y, because those are dependent upon what we choose for x. So the dependent variable is your output variable. It's what you get out of your function, and that's usually y. Or up here in this case, it could be f of x. Evaluate. So we want to be able to evaluate using the f of x notation. F of x equals 4x plus 5. What is f of 12? So I always like to just write the function underneath that because it helps me see a pattern in the notation. If we say f of 12, well 12 is then replacing the x in our function, which means it's going to replace the x on the other side of the equation. So if we replace this x with 12, we need to replace the other x with 12. All that notation is telling us is what would the function's value be if we plug 12 in for x? That's what this is asking. We're saying if x is 12, what does f of x equal? So f of 12 equals 4 times 12 plus 5. Well, 4 times 12 is 48. And then plus 5 would give us 53. So f of 12 equals 53. Same concept here. What is f of -3? Well, we're doing the same concept. We're just plugging in a different number. So we say f of -3 is equal to 4 times -3 plus 5. Replace your x's with -3. And then just evaluate. 4 times -3 is -12. -12 plus 5 is -7. So we have f of -3 is equal to -7. And last, if f of x equals 25, what is x? Now, if we write our function underneath that, we should see that we don't have a value for x. That is actually what we're looking for. Our answer needs to be x equals some number. What we do know, however, is that f of x is equal to 25, and f of x equals 4x plus 5, so using our transitive property, we can say that 25 would then be equal to 4x plus 5. Two things are equal to the same thing, then they're equal to each other. Now we have a nice pretty equation that we can use to solve for x. Undo plus 5 on both sides with -5. We get 20 equals 4x. Divide both sides by 4. We get x equals 5. So that would be our answer. Next piece, if you flip your note sheet over to the back, we have to talk about slope. Slope is super important to linear relations. Slope is your change in y over your change in x. It's your rate of change. Now we usually denote this by using a triangle for the word change, because you'll see it notated like that. We also commonly use rise over run when we're dealing with our graph. So that is slope. All right. So we're really going to focus on this change in y over change in x piece. Also, we use the letter m for slope. If you don't recall, m is your letter for slope. So we have let y equal 7x plus 3. If the value of x changes by 2, how much does the value of y change by? So we're saying if your change in x is 2, so if your change in x is equal to 2, how much does the value of y change by? What is your change in y? Okay, so we have this equation of m is equal to your change in y over your change in x. If we look at our equation, y equals 7x plus 3, we can know what our slope is. Our slope is the letter that's next to x. It's 7. So if we think about that, that's in y equals mx plus b form. Your slope is always next to your x. So we also know that m is equal to 7. So if we plug in the two pieces, that we know into our equation down here, we can solve for the unknown piece. So we can say m, which is 7, is equal to the change in y, that is what we don't know, over our change in x, 2. Now, we can solve for change in y by undoing this divide by 2 with multiply by 2 on both sides. 2 times 7 is 14. We get 14 is equal to our change in y. So if our value of x changes by 2, we can say our value in y is going to change by 14. Next one. If the value of x changes by 6, how much does the value of y change by? Again, same concept. We have our slope. We're still working with the same equation, so our slope is still 7. We have our change in x is 6. We need to know what is our change in y. We need to figure that out. So we set up our equation. M equals change in y over change in x. M is 7. Change in y is our unknown. Change in x is 6. We need to solve for change in y. So we'd multiply both sides by 6. We get change in y is equal to 42. So if your value of x changes by 6, that means your value of y is going to change by 42. That's all the notes I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.